Hello everyone, I'm Sam Delmerico, currently working as a software engineer at ARiA on the Esail Cloud platform. Thank you for taking the time to listen to our presentation. Esail Cloud is a training tool designed to help instill an intuition for ocean acoustics into prospective sonar operators, such that they can perform their duties effectively and efficiently. In this presentation, I'll give an overview of how Esail Cloud can be an invaluable tool in an instructor's toolbox. ARiA is a research and development firm with core capabilities in machine learning, numerical modeling, signal processing, and software engineering. We tackle real-world problems that cut across our core capabilities, where the tight cohesion of our teams of software engineers and research scientists enables ARiA to deliver fielded solutions at the leading edge of technology. Founded in 2010, ARiA is headquartered in Central Virginia with branch offices in Washington, D.C. and Seattle, Washington. Tactical oceanography is a hard problem to teach in a classroom setting because the instructor needs to instill an intuition for the mechanics of 3D underwater sound propagation while being limited to 2D instructional materials. Esail Cloud was designed to fill this instructional gap by giving NavAir trainers a better tool for teaching acoustic sensor operators about tactical oceanography. It will be initially deployed at the PAA-ITC at Naval Air Station Jacksonville in Florida. In our alpha version of the software, we'll deliver a few methods for content presentation to the student, depending on teaching style and instructor discretion. The instructor can choose to present recorded video demonstrations of the usage of the software in a particular scenario, or the instructor can share pre-constructed interactive scenarios to the students. Additionally, the instructor can assign the student to interact directly with a blank scenario inside the software and determine buoy target placement as an exercise or investigation. These assignments are integrated with the existing lesson management platform, Moodle, so the instructor can track student progress and success. Additionally, a game-based mode of the software allows instructors to evaluate students' proficiency as they actively plan and execute a buoy positioning strategy in attempts to locate an unseen target. This mode will score the efficacy of students' positioning strategy and will provide feedback to the instruction as to which educational areas need remediation. We're currently in the second year of phase 2, in which we plan to release our evaluated beta version of the software. In the option phase, we'll integrate our product with the ITC environment and evaluate its effectiveness in a live classroom setting. Then the product will be refined and evolved for the final deployment in phase 3. The traditional methods of teaching ocean acoustics phenomena in the setting of sonar operation largely suffers from the inability to convey intrinsically three-dimensional concepts in a two-dimensional classroom environment. On a whiteboard, for example, Esail Cloud addresses this issue in two ways. Firstly, it allows instructors to create custom videos based on real physical models of the environment and acoustics. And secondly, by providing an immersive 3D environment where students can actively manipulate and observe the response of three-dimensional sound. This aids the construction of mental models and the development of intuition that's critical for an airman to be successful in locating an unseen target. Esail Cloud takes a unique strategy for ocean acoustics education by allowing the student to combine disparate skills taught in the classroom in a single cohesive application that more closely mimics future duties. Instead of learning about sound propagation as parts of a whole, the student is exposed to all the features that contribute to underwater propagation in a single active learning situation. In order to do this, Esail Cloud utilizes real-world environmental data collected in OML databases to simulate physically realistic and high-fidelity scenarios that closely resemble situations that could occur in a real tactical situation. The realistic nature of the learning environment that's produced makes Esail Cloud attractive to other entities in the Navy that need effective tools for instilling their students with the intricacies of ocean acoustics in an applied context. These entities include the Helicopter Maritime Strike Squadron and training for environmental modeling on surface ships and submarines. The features that make Esail Cloud most attractive are its innovative approach of offering accurate physical modeling in a 3D environment. Since the environment's based on real physical phenomena, instructors can demonstrate specific aspects of a real-world scenario to students with a clear visual tool. In order to bring this product to fruition, our team focuses on correct physical modeling and visualizations, lesson builder and student evaluation tools, a clean user interface, and clear software guides for instructors and students. All of this is backed by a robust, scalable software architecture that allows Esail to run in a classroom environment as a local server, as well as a standalone application to run in tactical situations. Esail Cloud employs 5 milestones to ensure that we deliver a successful instructional tool. The first milestone, physical modeling and 3D visualizations, allows students to view physically accurate sound propagation between sonar buoys and underwater targets. This modeling takes into account factors such as undersea terrain, weather, and time of year. And current visualizations for sound propagation include ray trace paths, wavefront animations, and top-down and vertical cross-sections of relevant acoustic functions. Our second milestone, creating lesson builder and student evaluation tools, empower instructors to create a library of content for use in lessons and assessments. A scenario editor enables instructors to create custom scenarios involving multiple buoys and targets. These can be created in 2 ways. Firstly, by choosing a geographic location via latitude and longitude, and secondly, by picking environmental attributes, such as the presence of a deep sound channel or availability of a conversion zone. Instructors can then save these custom scenarios and share them with students, where they can be accessed via Moodle. Instructors can also record videos of the visualizations produced by their scenarios, and a game-based mode of the application allows the instructors to assess students directly within the Esail Cloud application. Our third milestone, improving user interface and usability, includes adaptable interfaces that hide away advanced options and controls so that the first-time users can focus on what is most important and learn the rest as they later explore Esail Cloud. There's also clear feedback that indicates when assets or results are loading, or if an error occurs, it explains what the cause is. Our fourth milestone is adding user guides and supports. To achieve this, we have added context-dependent hints and explanations to help guide first-time users while staying out of the way of experienced ones. And we will deliver a quick reference guide and software manual with the product. Finally, our fifth milestone is creating a scalable architecture. Our client-server architecture allows users to access the full capabilities of Esail Cloud through an internet browser in a classroom setting. And our second architecture is a standalone architecture that allows a version of Esail Cloud to run on Navy standard Toughbook laptops. Here's a quick overview of the advantages of Esail Cloud over current teaching methods. Esail Cloud offers physically accurate 3D simulations based on real-world data, which allows students to learn from real-life examples. Additionally, there's easy integration with Moodle lessons and assessments to aid with online learning, and students can interact with and explore visualizations in a full 3D environment, enabling them to learn and discover insights at their own pace. In order to ensure successful transition to the fleet, we will need successful demonstrations and interest from the NavAir MIPRA training, PMA 205 and PMA 290, as well as funding for the Phase 2 option, where we will test and integrate our technology with the ITC. This will give us end-user testing with students and instructors, and will provide critical insight to improve the features that provide the most aid to ITC trainers. We are currently ahead of schedule for Phase 2 base and are looking forward to tasks for Phase 2 option to improve Esail Cloud's standalone architecture. The commercialization strategy will be to pose Esail Cloud as a rapid content generation tool for instructors to create animated lessons and evaluate their students. The product transition will be targeted to Naval Air Station Jacksonville, PAA ITC, and PMA 205, which manages fielding of training systems, and PMA 264, which manages air ASW systems, as the client-server architecture for the classroom. In the future, Esail Cloud could be deployed outside the classroom as a tool for real-time tactical oceanography by integrating in larger-scale tactical training programs developed by Boeing, or as a TDA in MPT. At the moment, our primary advocates are Naval Aviation Training Systems and Ranges Program Office, PMA 205, and the Maritime Patrol and Reconnaissance Aircraft, PMA 290. We're working with NOC TSD to demonstrate our product this year at ITSEC and the NAVAIR ITC. We'll demonstrate our scenario builder and the capabilities that surpass traditional static methods of teaching tactile oceanography. If you would like to learn more about Esail Cloud, please get in touch. You can contact Dr. Jason Summers, the managing member and chief scientist at ARiA, at his contact information on screen, or feel free to contact myself at my contact information also on screen. Thanks for listening to this presentation, and we look forward to hearing from you.